All right, we are in section 10.3, the parabola. Okay, the parabola. So let's write down the definition of a parabola. This says a parabola is a set of all points okay, that are equidistant from a fixed line, from a fixed line called the directrix. Okay? And a fixed point called the focus. And a fixed point called the focus. That's the definition of a parabola. A set of points that are equidistant from a fixed line called the directrix, and a fixed point called the focus. So what do I mean? Well, suppose that's the x and y axis. So suppose we've got a parabola centered at with the vertex rather, at the origin, okay? Well, this point right here is called the focus, okay? And this line, this imaginary line, this is called the directrix, okay? So what we're saying is the distance, if I take any point x comma y on my parabola, suppose this is x comma y, this distance right here and this distance right here, these two distances, as I travel up and down this parabola either direction, the distance from a point on the parabola to the focus is equal to the distance from that same point on the parabola and the directrix. So I'm saying that this D1 is equal to D2. That's what it means to be a parabola, okay? Set of all points in a plane that are equidistant from a fixed point called the focus and from a fixed line called the directrix. So the directrix is this should be a horizontal line. It should be parallel to the x-axis. That's what it means to be a parabola, okay? Now, every parabola has an axis of symmetry. This would be the axis of symmetry of the parabola. In this case, the y-axis, okay? Because if I look at the positive half of this parabola, if you flip that across the axis of symmetry, you get the other half of the parabola. So it's symmetric with respect to the y-axis. That would be the axis of symmetry, okay? The vertex of the parabola would be right here. This point is called the vertex, okay? That's where it changes from a decreasing function to an increasing, or vice versa, where it changes from this function is decreasing, hits the vertex, it becomes increasing. That's the vertex, okay? They say the distance between the vertex and the focus of the parabola is called the focal length. The distance between the vertex, right here, and the focus, so this distance right here, is called the focal length. The distance between the focus and the vertex, that's called the focal length. And this distance right here is the same as the distance from the vertex to the directrix. The focal length, the distance from the vertex of the parabola to the focus, is the same as the distance from the vertex of the parabola vertically down to the directrix. That focal length is the same. Okay? All right. Well, how do we graph these parabolas? Well, there's two cases of parabolas. Okay. So, standard form of the equation of a parabola. Standard form of equation of a And this is on page 942. Okay? So if the axis of symmetry is the y-axis, there's going to be two cases. One where the axis of symmetry is the y-axis. Second case is where the axis of symmetry is the x-axis. Those are the two cases we're going to consider. The one we drew right there, the axis of symmetry, was the y-axis. Okay? So if the axis of symmetry is the y-axis, the equation, right? So the equation would be x squared equals 4py. X squared equals 4py. We're going to talk about what p is in a moment. Okay, x squared equals 4py. P is a constant, so we're going to talk about it a little more in a minute. Okay? If the axis of symmetry is the x-axis, the equation would be y squared equals 4py. Okay? The axis of symmetry was the x-axis. The equation, oh, this is an x. This is an x. Y squared equals 4px. That one says x squared equals 4py. Okay? Excuse me. The vertex. The vertex, 0, 0 in both cases. Okay? Again, this chart is on page 942. Page 942. Make sure you take a good look at it. The focus is at 0p. So whatever that p is, x squared equals 4py, the focus would be at 0p. For the axis of symmetry on the x-axis, the focus would be at p0. Okay? The directrix would be y equals negative p here. If the axis of symmetry is the y-axis, okay, y equals negative p. If the axis of symmetry is the x-axis, the equation would be x equals negative p. Okay? Axis of symmetry, we already said that. The axis of symmetry well, again, axis of symmetry is the y-axis. The equation for the y-axis is x equals 0. When x equals 0, that's the y-axis. If the axis of symmetry is the x-axis, y equals 0 would be the axis of symmetry. Okay? And they show you graphs for each one of these. Okay? They show you graphs, and there's going to be two cases. So for this one, p can be greater than 0 or p can be less than 0. Okay? If p is greater than 0, it looks like that. If p is less than 0, it looks like that. So there's y equals negative p. There's the focus at 0, comma p. Okay? Here, y equals positive p would be the directrix, right? And your focus would be at 0, negative p. Again, the sign of p, no, it's still y equals negative p. That's still y equals negative p. Because p is negative. So when you say negative p, that makes the y a positive 1. And remember, this is the x-axis where x is 0. Okay? So, and you got the same two cases here. Take a look at that in your book. I can't do the graphs that much justice. So please open your books, take a look, and you'll see exactly the 4 different possibilities. Again, p greater than 0, means the parabola opens upward, right? When P is greater than 0, the parabola opens upward. When P is less than 0, it opens down. For these two cases, the parabola is either going to open on the right, this is P greater than 0, or the parabola will open on the left. The directrix would look like that. Focus would be here, focus would be here. Again, look at your book. Look at your book. This is that. Okay? So, these are parabolas. So let's see if we can learn a little more about parabolas. Example 1. Example 1. We're on page 943. Example 1, page 943. This says an engineer designs a flashlight. So read the problem. I'm not going to write all of this. Read the problem in the book. An engineer designs a flashlight with a parabolic mirror. A coordinate system is chosen so that the vertex of a cross section through the center of the mirror is located at 0, 0. So what are we saying? The picture will help us out a lot. There's a parabolic mirror. Okay? There's a parabolic mirror centered at the origin. Okay, the vertex is at the origin. Okay? And they say that the equation of that parabola is x squared equals 8y. Okay? And they want to know where should the bulb be placed. So this is, you can think about this parabolic mirror. Okay, he's designing a flashlight. So he's going to put a bulb somewhere up here. And the light beams are going to come down. And whenever you hit a parabolic mirror, the light reflects back vertically. Okay? If it comes down here, it hits the mirror, it goes up vertically. And it should be perfectly vertical. All of these should be parallel to the y-axis. Okay? When light hits a parabolic mirror from the focus, I should say, it goes straight up. So the question is, where should he place the bulb? The bulb is going to be placed, and if you place the bulb at the focus, again, those light beams direct out. So think about this as a flashlight. There's my flashlight, and it's shining this direction. So the bulb, well, I didn't draw that right, so sorry. Okay? The idea I gave you about the light beams is correct. Let's just leave it at that. Okay? And again, where does he place the bulb? And again, the ideal place to place it is at the focus of the parabola, right? I want to place that at the focus of the parabola. So again, this thing has a vertex at 0, 0. Okay? I know the equation of the parabola. Okay? Where should the bulb be placed in order to make use of the reflective property of the parabola? That is, find the location of the focus. So A, find the focus. Find the focus. So again, x squared equals 8y. That looks like him. X squared equals 4py. So let's compare the two equations. X squared equals 8y is our specific example. There's the general form of a parabola. So I can conclude that 8 is equal to 4p. Divide by 4, p must be 2. P is 2. Well, the focus is going to be at 0, comma, p. So that means the focus better be at 0, comma, 2, according to that chart. So he needs to place the focus at 0, 2 in order to maximize the reflective properties for that parabola. B says write an equation of the directrix. So B, what's the equation of the directrix? Well, the directrix is just y equals negative p. So since p was 2, y equals negative 2 would be the equation of the directrix. So nothing hard about that. Nothing hard about that. Next, they graph a parabola. Next thing we're going to do is graph a parabola. parabola. We're looking at example 2. Graph x squared equals negative 12y. So example 2, consider x squared equals negative 12y. Okay? Part A says identify the vertex, the focus, and focal diameter. Identify vertex, focus, and focal diameter. I didn't mention focal diameter a moment ago, but it's a very simple concept. We've identified the focus of this parabola, right? If I drew a straight line through the focus that hit the parabola, right? If you draw a line through the focus that hits each side of the parabola, this length right here, that would be the focal diameter. It's always the length. Once you identify your focus, draw a line parallel to the directrix through the focus, such that that line intersects each half of the parabola. The length of that line will be the focal diameter. Okay? So identify the vertex, focus, and focal diameter. So again, x squared equals negative 12y. It still has that same form. It looks like this. So I can conclude that 4p is the same thing as negative 12. X squared equals negative 12y, or x squared equals 4py. The 4p must be negative 12. Divide by 4, p is negative 3. So the p is negative 3. Okay? Well, the vertex is 0, 0. This is a parabola centered at the origin. So the vertex is 0, 0. That's easy. Whenever the y is 0, the x must be 0. So this thing has to go through the point 0, 0. Okay? The focus, since I know what p is, the focus would be at 0p, comma p, but p is negative 3. So the focus would be 0, negative 3. Okay? The focal diameter, and they're going to make us graph it. So let's just go ahead and graph it and see what we got. Okay? x1 okay? So I had a vertex at 0, 0. I had the focus at 0, negative 3. Okay? P is negative 3. Okay? So this thing opens downward. The parabola is going to come down like this, come down like that. Okay? And I want to know its focal diameter. Well, remember I said that the focal diameter, if I drew a line through the vertex, I'm trying to figure out where this parabola intersects the vertex, right? This point and this point, and then this distance from here to here, that'll be my focal diameter. Okay? That distance from there to there. Well, what I have to realize is, again, I'm going through the focus, right? The focus. This focus is always at y equals at p. P is negative 3. Okay? So the focus will always go there. That was on that little chart we had a moment ago. The focus will always be 0, comma p. So the y coordinate of the focus is always p. So when I see this 4py, so when y equals p, you get x squared equals 4p times p. Because again, y has to be p if you're going through the focus. Okay? So x squared equals 4p squared. Take the square root of both sides. X is plus or minus, and this should be absolute value. This is how I'll find those 2 points. This is how you find two points to determine focal diameter. So what do I mean? So in this case, P was -3. So X should be plus or minus 2 times the absolute value of -3, according to what I just said. Plus or minus 2 times 3, because the absolute value of -3 is 3. So plus or minus 6. Plus or minus 6 should be my focal diameter. So 4, 5, 6, and again, this is not the scale. So the parabola has to do this. Okay, so get rid of that stuff. And that was just for illustration. 4, 5, 6, and it will do this. So this will be the point 6, -3. This will be the point -6, -3. And this line segment that goes from here to here, that represents my focal diameter. So since I'm going from -6 to 6, if you go from -6 to 6, you go 12 units. So the focal diameter is 12. The focal diameter is 12. And the focal diameter is important because that gives us an idea of the curvature of the parabola. So I didn't really need to draw that line segment, but it for sure helped me determine the curvature of my parabola. Now I know exactly what my parabola looks like. So that's how we're going to graph these parabolas. And if you wanted the directrix, the focus was at 0 and -3, so the directrix would be right here at y equals 3. Remember, y is -p. P was -3, so y is -p. -3 makes a +3. So the directrix would be at y equals 3. So there's the graph of that. So again, this is how we're going to find those 2 points that will help us to find our focal diameter. X will be plus or minus 2 times the absolute value of P. Okay. Example 3. Example 3. Make sure the video is still working. Okay, example 3. They say, given 2y squared equals 32x. Given 2y squared equals 32x. Okay? So A, identify vertex. They say focus and focal diameter. Focus and focal diameter. Okay? Well, the first thing to do is put it in standard form. I don't want 2y squared, I want just y squared. So divide both sides by 2. So y squared equals 16x. Okay, y squared equals 16x. So now I'm going to compare that to my standard form. There's my standard form for a parabola centered at the origin with a horizontal axis of symmetry. A horizontal axis of symmetry. Horizontal axis of symmetry. This one still had a vertical axis of symmetry. The axis of symmetry for this one was here. Axis of symmetry is the y-axis, or x equals 0. For that graph, the axis of symmetry was the y-axis, or x equals 0. But since I have y squared equals 4py instead of x squared equals 4py, this time the axis of symmetry won't be the y-axis, but it'll be the x-axis, which is y equals 0. This will be my axis of symmetry. So I can determine that right away. Y equals 0 will be the axis of symmetry for this graph. Okay. Well, so y squared equals 16x. Again, the general form is y squared equals 4px. So 4p must be 16. So p must be 4. P must be 4. Okay. That's always your first step. Determine what P is. P has to be 4. Well, the vertex is at 0, 0. Okay, that's one thing they asked us, the vertex. They want the focus, but the focus will be at, will be at P comma 0. So since P was 4, the focus is at 4 comma 0. Focus is at P comma 0. So 4 comma 0. Okay? All right. Next thing is the focal diameter. The focal diameter. But again, we said to calculate the focal diameter, plus or minus 2 absolute value of P. So x equals plus or minus 2. P is 4. So absolute value of 4. So x is plus or minus 8. So I'll go to my vertex. I'll go 8 units. And again, my axis of symmetry is horizontal, right? So my parabola will either open like that or like that. But since P is greater than 0, it's this one. My parabola is going to open that way. Okay? So I'm going to plot my vertex. At 0, 0. Okay? All right. My focus is at 4, 0. I'm sorry. 1, 2, 3, 4. 4, 0. That's 4, 0. Okay? So 1, 2, 3, 4, 6, 7, 9, 10, 11, 12. Okay? So my focus was at 4, 0. Focal diameter is plus or minus 8. Okay? Vertex is 0, 0. There's my focus. So and again, I know this parabola opens like this. Okay? But I don't know if to make it like narrow or do I make it curve way out like that. That's what the focal diameter does for me. Okay? So I go over here at the focus, and since the focal diameter is plus or minus 8, I'll go 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. I'll go 8 units down. Down 8. That tells me the curvature of the parabola. So my focal distance goes from -8 to +8, so the focal diameter is 16. The focal diameter turns out to be 16. Okay? They said plot it. We essentially just did. Okay? So nothing hard about that. So again, that focal diameter is critical for graphing these. There's my line segment that illustrates my focal diameter. That line has length 16. Okay, I went 8 up from my focus and 8 down from my focus. That's a total of 16. So that focal diameter helps me define the curvature of the parabola. That focal diameter helps me to define the curvature of that parabola. Okay. All right. The next thing is graph a parabola with vertex h comma k. Graph parabola with vertex h comma k. So parabolas don't have to have a vertex at the origin. The vertex for a parabola can be any point in the plane. Okay. So if you want to graph a parabola with vertex h comma k, well, again, 2 cases. You could have a vertical axis of symmetry. Or you could have a horizontal axis of symmetry. Okay? So if you have a vertical axis of symmetry, the equation becomes x minus h squared plus, or equals, I'm sorry, 4p y minus k. If you have a horizontal axis of symmetry, the equation becomes y minus k squared equals 4p x minus h. Okay? Well, the vertex, just like we did before, the vertex will be h comma k in both cases. The focus, if it's a vertical axis of symmetry, we'll have h, k plus p, h, k plus p. If we have a horizontal axis of symmetry, it'll be h plus p, k. That'll be my focus. The directrix, for a vertical axis of symmetry, y equals k minus p. For a horizontal axis of symmetry, x equals h minus p. Okay? Finally, axis of symmetry. Okay? If you have a vertical axis of symmetry, it'll be x equals h. If you have a horizontal axis of symmetry, it'll be y equals k. Okay? And again, that's just these things where the center is no longer the origin. Everything we did works the same way now. Okay? So all you're doing is moving the vertex from the origin to some point in the plane, and everything we talked about over there just changes accordingly. The vertex move over to wherever the center is, the vertex is. The focus, you'll adjust the focus. Instead of h comma k, it'll be h comma k plus p. You're going to determine p the same way you did before. Okay? So let's just do one. Example 4, given. They say y plus 3 squared. Y plus 3 squared equals negative 4 x minus 2. Okay? Well, that one looks like him. So we've got a horizontal axis of symmetry. It looks just like y minus k squared equals 4p x minus h. So comparing those two equations, my vertex is really easy. Vertex will be 2, negative 3. Okay? Well, I need to figure out p. Negative 4 better be the same thing as 4p. So p, divide both sides by 4, p turns out to be negative 1. Okay? P turns out to be negative 1. So according to this, to get my focus, it'll just be my center, the x-coordinate of my center plus p comma k. So the x-coordinate of my center, the focus, I take the x-coordinate of my center and I add p. So 2 plus a negative 1 makes 1 negative 3. I'm just using that formula. The focus would be at 1 negative 3. Okay? The focal diameter, so x equals plus or minus 2 times the absolute value of p. P was negative 1, so this is plus or minus 2. Okay? So let's see what we got. X, y. So my vertex is at 2, negative 3. So 2, negative 3, there's my vertex. My focus is at 1, negative 3, right here. Okay, there's my focus, there's my vertex, okay? And again, I knew that this had a horizontal line of symmetry. There's a horizontal line of symmetry. Okay, there's a horizontal line of symmetry. So, This is the axis of symmetry. Okay. Axis of symmetry, y equals k. So k was -3, so y was -3, right here. That's the axis of symmetry. Okay? Now, I take my focus, right? And since the focal diameter is 2, so 1, -3 is right here. So that means I go up 2, I go down 2, 1, 2. So the focal diameter is the distance from here to here. So these are 2 points on the parabola. The focal diameter would be from -1 to -5, so the focal diameter is 4. Focal diameter will always be 2 times whatever that number is. Focal diameter turns out to be 4. Plot it. Okay, we did that already. The directrix, since the focus and the vertex sit 1 unit apart, the directrix would be right here. This would be the directrix. Okay? That would be the directrix at x equals +3. Okay? So, that's how we graph these parabolas where the center is no longer the origin. Or not the center, but the vertex is no longer at the origin. This is how we'll graph these things. So we got a nice little chart that you can use to help you out, and I don't mind you using that. Whether we're talking about parabolas, hyperbolas, I don't mind you using these things to help us get these graphs. Okay. Well, just like before, when we talked about hyperbolas and these other things, circles before, example 5, they give us a parabola, and they say, I'm just going to say write in standard form. Because we've seen with these other geometric figures, they're not always in standard form. So I've got 4x squared minus 20x. They say minus 8y plus 57 equals 0. So I want to put it in standard form. So I got to complete the square. So I group the x terms, all right? And then I take everything else to the other side. Group the x terms and take everything else to the other side. The -8y moves to the right side of the equal sign, becomes +8y. The +57 that's on the left side of the equal sign moves to the right side and becomes -57. So now I need to complete the square on the x. First I'll factor out, because whenever you complete the square, you want a 1 in front of the x squared term. So x squared minus 5x, okay? And again, this didn't change. Okay? Well, now I complete the square. I take half of -5 and I square it. Half of -5 squared gives me +25/4. So that's what I have to add to make this a perfect square. But there's a 4 out in front. So think about that. 4 times 25/4, because the 4 multiplies by that. That's what I'm really adding to this side, and that's what I'm going to have to add to that side. But 4 times 25/4, the 4 is canceled, so that's really just 25. So if I added that term over there, I got to add 25 on the other side, because really what I did was add 25. Okay? To keep it balanced. I added 25/4, but there's a 4 here. 4 times 25/4 is just 25, so I added 25 there. I've got to add 25 over there. All right. Well, the 4 is still here. This thing is now a perfect square. There's the 8y. -57 plus 25 is -32. The factoring comes for free. There's the x. Half of -5 is -5/2. Okay? The last step is to divide everything by 4. If I do it over here, I do it everywhere. So that'll give me x minus 5/2 squared. 8 over that makes 2y minus 16. Okay? And factor the 2 out. Okay? And that's a 4. 32, 32 divided by 4, that was 8. I'm sorry. That was 8. Now that's a 4. That was 8. 8y minus 32. Yes, yes. Okay. All right. Yes. So there's my standard form. There's my standard form. Okay. So you just complete the square to get to the standard form. All right. Then they say identify the vertex, focus, and focal diameter. Well, that's the same stuff we've been doing. It's just like the one we just did, so I'll leave that to you. I will do example 6. Example 6. Example 6 says determine the standard form of the equation of a parabola. Determine standard form of the equation of a parabola. Okay? With focus 1, 2. Focus 1, 2. And they say directrix x equals 7. Directrix x equals 7. So determine the equation, the standard form of the equation of a parabola with focus 1, 2 and directrix x equals 7. So, one, 2, 3, 4, 5, 6, 7. So x equals 7. That's my directrix. Okay? Focus is 1, 2. One, 2. There's my focus. So there's my focus. There's my directrix. Okay? Well, I've done enough of these things to know the focus sits a distance of p units away from the center. Okay? The focus sits a distance of p units away from the center. So since this focus and the center, not the center, but the vertex, I'm sorry. The focus sits a distance of p units away from the vertex. And the vertex is halfway between the focus and the directrix. So since there are 1, 2, 3, 4, 5, 6 units from my focus to my directrix, that means that my center must sit 3 units away. So 1, 2, 3. My center is the point 4, 2. The center of that parabola better be the point 4, 2. All right? And we've determined what P is. P has to be, and wait a minute though, I know, the other thing I know is that if this is the focus and that's the center, and there's my directrix, this thing has to open like this. Okay? So I know the length of P. P is 3, but P is a negative 3 since it opens this way. So P is negative 3. P is negative 3. So now, I've got a parabola whose axis of symmetry is horizontal, right? So it's going to be y squared equals 4px, excuse me. That's my general form. And no, this is one that's not centered at the origin, so y minus k squared equals 4p x minus h. That's what we want to write. The center is at 4, 2, so y minus 2 squared equals 4p, but we know what p is. P is negative 3, so 4 times negative 3 makes negative 12, x minus h, but again, the center was at 4, 2, so the h is a 4. So that would be the equation of the parabola. That would be the equation of the parabola. Y minus 2 squared equals negative 12, x minus 4. There's one more example you can take a look at. It is a very easy example. If you get stuck, let me know. But this concludes this section about parabola.